I'm only one call away. I'll be.
Hi, my name is Amirul Hafiz bin Abdullah, and today I would like to share some knowledge about aircraft flight control fly-by-night. Aircraft flight control was traditionally accomplished through mechanical and hydraulic systems, which is known as fly-by-wire. The next generation technology is by using fiber optics in flight control system, which is known as fly-by-light. Why it is used in the technology nowadays? Because it is not affected by electromagnetic interference (EMI), lighter and has high bandwidth. So, firstly, I would like to share some knowledge uh, about EMI, which is electromagnetic interference. It is also known as radio frequency interference, which is a disturbance generated by an external source that affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. Both man-made and natural source generated changing electrical currents and voltage that can cause EMI, such as automobile ignition systems, cell phones, and thunderstorms. Nowadays, aircraft designers have been turning to composites in order to make their vehicles lighter, more fuel efficient, and more comfortable for passengers. The increasing use of composite materials in aircraft structures has decreased EMI shielding previously provided by metal structures. Consequently, fly-by-wire are subjected to greater electrical interference, which can degrade performance of aircraft flight control. Therefore, today aircraft flight control is used fly-by-light.
The application of the fiber optic cable technology in an aircraft hold much future promises. This is due to the several advantages of a wire-based system that has been using right now. By replacing the flight control system electrical wiring with the optic cable, the weight and the volume inside of the aircraft can be reduced. In example, the F-15 fighter can save up to 57 kg, while the transport aircraft can save up to the 680 kg. Due to the fact that the optic cable are dielectric, the problems such as electromagnetic pulse, electromagnetic interference, and lightning can be eliminated. The high bandwidth capability offers the potential to all average data to be transmitted over a single line. It also can eliminate the fire threat due to the short circuit. That's all.
I will explain the basic system of a fly-by-light. The source from the pilot will be sent to an analog or digital interface. Then it will be sent to a transmitter, which consists of three main parts, which is voltage to current converter, light source, and source to fiber interface. A VCC will convert a voltage current into a current and then will be sent to a light source. The light source will convert the current input into light, and then the source to fiber interface will be the output which will be connected to a fiber optic cable. The output of the transmitter will be sent to the receiver via a optical fiber cable. At the middle of the optical fiber cable, there will be a signal regenerator which amplifies the input. In a receiver, there are three main components. The first component is a fiber to light detector interface. It will detect the light input from the transmitter. And then the second component is a light detector, which convert the light input into current. The third component is a current to voltage converter, which convert the current input into voltage. The current to voltage converter will send the input to the analog or digital interface.
Now, I'd like to conclude the summary for the fly-by-like (FBL). Okay, the challenge of those involved in aircraft control system hardware development is to accommodate the ever-increasing complexity in aircraft control, while limiting the size and weight of the component. Actually, the fly-by-like is the improvement of the fly-by-wire, which generally is to reduce the component weight and size. Okay, the primary advantages of the employing optical fiber is passive optical sensor and optically controlled actuator are reduced in weight and volume, while immunity from the electronic effect. It also has the high bandwidth capabilities and freedom from short circuit. Actually, since 1975, NASA has been performing in-house contract and grant research in fiber optic sensor. NASA already done the research for the fiber optic sensor, which using the high temperature electro-optic switches and fly-by-light control. Passive optical sensor development is an essential yet challenging area of work and has therefore received much attention during this period. So, in addition to a summary of the benefit of fiber optic, the FOCSI program, Sensor Advance and Future Direction in the NASA Lewis program, it will be discussed and decide what's the best for the fly-by-like. Alright, thank you.
Can't keep my hands to myself. No matter how hard I'm trying to.